So in this simple video, we'll discuss a fairly elementary concept. It's actually quite simple. We'll discuss the halogenation of benzene. So one thing you need to know, benzene is a generally stable compound. So benzene looks like this. Benzene is a fairly stable compound, and so it does not react anyhow, right? So it can participate in a total of 5 reactions, of which we'll talk about them individually. So before we can talk about the reactions, there's one thing I thought I should bring into perspective first. So the first concept is the concept of covalent bonds. So you need to know oxygen normally bonds to two things. It should make 2 covalent bonds, right? And so the important thing you need to know is this. If oxygen makes more covalent bonds than it normally does, suppose it made 4, it becomes a hydronium ion, right? Which carries a what? A positive charge. If it makes less bonds than it's supposed to, it bears a negative charge. So this is a very important concept. You could see this trend with many other elements apart from oxygen. So nitrogen, for example. In ammonia, nitrogen is bonded to 3 things, like that. So if ammonia is bonded to less than 3 things, it bears a negative charge. If it's bonded to more than 3 things, it becomes ammonium, right, which bears a positive charge. This is a very important concept that you need to take note of. Yeah. So another thing to take note of is the fact that in order for you to react benzene, especially with a halogen, right, in most Fidelcraft reactions, you need to use a Lewis acid catalyst. Reactions cannot occur without a Lewis acid catalyst, and in most cases, you either use aluminum trichloride or you'll be using iron trichloride, any one of the 2. And so I'll show you how that is done. So that means in order for this reaction to occur, if you want to add a halogen, right, you need to use either one of these. So I'll choose iron trichloride, but the mechanism is the same for aluminum also. So what do you expect to produce? What do you expect to produce? So you expect to produce 1, you expect to retain your catalyst, because we define a catalyst as a chemical species that when it participates in a reaction is retained, right? So what else will you produce? You produce hydrochloric acid, and then you also have your chlorobenzene, like that. So explain how that is done. So the best way is to chunk the steps of the mechanism into 4 steps. So in the first step, what do? We generate. What do we generate? We generate our electrophile. So how do we generate our electrophile? We start with the chlorine. So you say chlorine, you write the Lewis form. This is that, right? And then you react this. React it with what? With our Lewis acid catalyst, which is iron trichloride. When you react those 2 things, one thing you need to know is iron is in the D block. Because it's in the D block, it has unfilled, let me say, slots for electrons. And so what can happen is that this pair of electrons could move towards the iron there. And then when that happens, you form a complex. You form a what? You form a complex. And so you have this. You form a complex. So the electrons are here now. This complex could be called the catalytic complex, or in some literature they'll call it the sigma. What? Sigma complex. Right? We'll call it the sigma complex. This complex is very important. Let's analyze this structure. Is this structure stable? So iron is quite okay for now, at least, having a negative charge. But then let's comment on the charge of the other things. How many things is this chlorine bonded to? 1 thing. Is it happy? Yes. How many things is this chlorine bonded to? It's bonded to 2 things. What did we say before? When something is bonded to more things than it's supposed to, it gains a positive charge. Let me write that charge properly. So it gains a positive charge. So that means this chlorine is positively charged, and it's not happy being positively charged. What's the only way it could lose this positive charge? Is to extract this pair of electrons. And then when that happens, this chlorine will be, the bond will break here, and then this chlorine will be left alone, and then you have this. So this will have, okay, this will look like that, right? It will look like that. And so let's comment on the charges. What do we say about this? Normally chlorine or any halogen should bond to 1 thing. If it's bonded to less than 1 thing, what will happen? And then one thing you'll be able to see is that this will have what? Will have a deficiency of electrons. So when something is deficient of electrons, what do we say about the charge? We say the charge is positive, right? And then what can we comment here? This will return back to a formal charge of 0, right? And then we still have our pair of electrons there. So we have our sigma complex, and then the sigma complex is broken down. So we call this positive version, or this positive chlorine, we call this the electrophile. We call this the electrophile. And then what do we call this? We call this the conjugate base. We call this the conjugate base. So that's our step 1. Step 1 is done. So what do we do in step 2? So in step 2, we're doing aromatic attack. Apologies, my markers are not really good. Okay, so we do aromatic attack. So in aromatic attack or electrophilic attack,